So we're going to walk through the review for your quiz, which should be a very easy and straightforward quiz as long as you pay attention to some key things. So we're dealing with normal distribution. So if you go to Statlet, you have normal distribution. And you'll see there's a mean and a standard deviation. So the example on the left, we have a mean of mean body weight of 63.1 kilograms. And we have a standard deviation of 4.2 kilograms. So that's a notation that's typically used. And if you look at the little Statlet drawings, you can see they use the same notation as well. So then we have mean body weight of 92.3, standard deviation of 12.5, and those match right there. All right. Okay. So the first question is, what is the probability a runner's weight is 60 kilograms or greater? And probability is just the percentage of the area. How often does it happen? So we'll put in, what did we say it was? 63.1 and 4.2. And we wanted greater than 60 kilograms. So that's to the right. And we want 60 as the boundary. And you calculate the area and you can show the labels. And you can see right there, there is 0.7698 is the area. Now it did say percentage. Oh, it said probability, so it doesn't matter. I would probably give the decimal values then instead of the percentages. But here it says percentage, so we'll give percentage on the next one. What percentage of weights are between 65 and 70 kilograms? So you pick between two values, 65, 70. And mine is given in decimals, 0.2753. Move the decimal 2 places, and that gives you 27.53%. What is the weight cutoff for the heaviest 20% of runners? So now this is different. We have to switch on our drop down here because we've been calculating areas, which are percentages or decimals or proportions. We want to switch to calculating a value, and we want the heaviest. So the heaviest 20%, heaviest weights are on the right. So you go, okay, right area, and we want a 20%. So you put 0.20, don't put 20, 0.20. And you can show labels on the plot, and it shows 66.63, so 66.63 pounds. How about the lightest 10%? Well, that would be to the left, 0.10, calculate value, 57.7, right there. And then they said the middle 40%, that would be the central, and make sure this area matches. And you get 60.9 to 65.3. They asked for the low end, so it's a 60.9 pounds. We'll go ahead and just run through it again with the ones on the right. So pretty much the same idea. Now I'm going to put 92.3 and 12.5. 92.3, 12.5. And I can plot my distribution, but I'm not starting back at the beginning, which was percentages and areas and probabilities. Make sure you're on that drop down there, okay? It's the default drop down, so that's the good news. So 100 kilograms or greater, so we go to the right of the value, 100. Calculate area, and you can see it's 0.2689, so that would, and it said percentage here, so I'm going to change it to 26.89%. Okay. What percentage of weights are between 95 and 105? So I just go between two values. What did we say? 95 and 105, I think? Let's see. I'm getting 0.2597. It was between 95 and 105, so 0.2597. And then now we're going to get to the last three problems where we're looking at cutoffs. So actual values, so I have to change the drop down, and we're looking at the heaviest 10%. Change your drop down first, calculate a value. We want the heaviest, so that's on the right side, and I think it was 10%. And I'm getting 108.3. 108, yes, 108.3 is the heaviest 10%. So these are the heaviest guys. The lightest 25%, that's on the left. So change 0.25, go for the left area, calculate, and I get 83.9. And oops, Yeah, I just forgot to change. I wonder where that number came from. 83.9. Let's make sure. I was looking at the 79.8 right before it. So it should be 83.9 pounds. All right. Then the middle 60% here. So we'll go central. 0.6. Calculate. And we have 81.8 to 102.8. And I think we wanted the lower value. So that's your 81.8. All right. Now, if you go to the back side of the review, we talk about doing z-scores. So what we have to do is we have to use the mean of 0 and 1. So automatically, I need to go back to my staplet, change the mean from 0 to 1. This is a standardized, actually. And so I wonder if it'll remember so if what was the original value before? It was 92.3 and 12.5. 92.3. Doesn't matter really what I put up here, but I was just going to put the last one. And I'm just picking values, ignore it. So when you hit show labels in the plot, do you see here how it shows the N with the 92.3 and the 12.5? When we switch this to standardized, we have a mean of 0 and a standard deviation of 1. So watch what happens right here when I hit plot distribution. It started to say standard normal. So let me show you. It will. Let me come back down here. So when doing z-scores, we've got to use a mean of 0 and a standard deviation of 1. I want 58% of the area to be to the right. So I'm actually not calculating a area. I'm calculating a value. I know the area is 58%. And make sure you pick to the right. Calculate value, and I get a z-score. You can see here's the z. And if you have the standard deviation here, let me show the labels. If it says standard normal distribution, it kind of knows you're doing the z. So z equals negative 2.019, which pretty much matches. That's slightly rounded right there. Now we can find z such that 15.2% is to the right. So you do 0.152. Remember to move the decimal. Make sure it's right. What did I do was it to the right? To the left? I was like, wait a second. That's kind of weird. I didn't change it. I did change it. And so you get your z as negative 1.028 or negative 0.103, depending how you round it. So that's a z-score right there. Finally, find z such the middle 90%. So you go, okay, middle 90%, central. 0.9, calculate, all right? And so they want the z. See, there's a negative z and a positive z. So the question is asking find z, give them the positive z. All right, so in fact, I might add that little note. Give a positive z for these, all right? So that's a general thing. And so our z is 1.645. All right, now let's go to the partner A. 23% of area lies to the right. So both of these are doing standard deviations. I mean, the standardized normal distribution, z-scores. So I don't have to change this. I can just go back in, and I think we said 23% to the right. Yeah. So I'll change bright area, 0.23, calculate value. And I get 0.7388, probably 0.7. Yeah, there it is, 0.7388. And that's your z-score, all right? And then find z such that 18% is on the left. So we go left area, 0.18, calculate our value, negative 0.9154. So, and remember, if it's before the average, you're going to have a negative z-score. Above average is a positive z-score. So don't forget the sign on your z-score, okay? So there you have the negative 0.9154. Find z such that 80% of the area is to the right. So we would do 80%. Go to the right. Calculate. And I get negative 0.8416, which matches, hopefully, 18% to the left. Oh, I'm doing 18% to the left. I said 80% to the right, didn't I? 18% to the left. Helps if I do the right problem. It's like, that doesn't match. Okay, negative 0.9154. It's right there. And then finally, here we go. And then, okay, that's what happened. I was reading 8 and trying to do 7. 18% to the left, so I got the negative 0.9154. And finally, in the middle, 80%, and we're going to report the positive value. So central. And there's our 80%. And the positive value is 1.2816, which is right there. So hopefully this all makes sense. If you still have some questions, feel free to bug me before making up your quiz.